Okay, you are welcome back to Introductory Mathematical Analysis B. We are still in session 14.7 where we are dealing with definite integral. Okay, in the last video, if you have not watched the last video, make sure you watch that one. In the last video, I promised that I'm going to show the two sides of this in definite integral. Okay, so the first side is that when you are given a definite integral, you can actually make it indefinite. Okay, so now I want to solve this, I want to evaluate this, and it's a definite integral from 1 to 2. Okay, so I know I need to use substitution because of the way it is. Okay, so if I use substitution on this, let me call this one method 1. In method 1, I want to use substitution, but I will not carry the limit along with me. So I will now say I want to evaluate taking this. Okay. Taking that one. Okay, so you see, I drop the limit of integration. Okay, I take this. Now, in order to evaluate this, I will say let my u equals to t squared plus 1. Okay, so the u will now become 2t dt, and then the u over 2 becomes t dt. Okay, all right, now I can change this into u now to become, but before I change it to 2 to u, let me rewrite it as this. Okay, let me write it as this. Then I can now change into u raised to power 3. Then this become du over 2. Okay, all right, this is the same thing as 1 over 2 u3 du. Okay, so if I integrate this, it will be 1 over 2 multiplied by u raised to power 4 over 4 plus c, because we are dealing with what? With indefinite integral. We are dealing with indefinite integral. Okay, I can add plus c there. Okay, now this becomes what? This becomes u raised to power 4 over 8 plus c, which is now, what is our u? T raised to power 2 plus 1 raised to power 4 now, raised to power 4 all over 8 plus c. That is what I got when I just take only the indefinite integral. Now I need to bring it back. Don't forget I'm asked to evaluate the definite integral. So if I now want to evaluate the definite integral, so my 1 to 2 of t squared plus 1 raised to power 3 dt becomes, don't forget I've already evaluated the integral. So it becomes, this is the answer, but it will now be from 1 to 2. Don't put integral again. You have already evaluated the integral, so there's no need to put integral. I just put my answer, t squared plus 1 raised to power 4 over 8 plus c. Then I now put this square bracket from 1 to 2. See, I do not put the integral anymore. If you put the integral, it shows that you are now integrating the second time. So there's no need to put the integral anymore. You only need to evaluate from 1 to 2 of t. Don't forget you change back to t. All right. So you just evaluate that. What do you get that? When you put 2, it will be 5 raised to power 4 over 8 plus c. I put it along with me. Then minus 1 raised to power 2, which is 1. Then it will now be 2 raised to power 4 over 8 plus c. Okay, you see, that's what I mentioned in the last video, that in definite integral we don't need a constant, but because we took the indefinite integral from the definite one, that's why we have this constant. But let's see what it will happen to that constant. By the time I open the bracket, this will become 5 raised to power 4 over 8 minus, this will be plus c, then minus 2 raised to power 4 over 8 minus c, because when you open the bracket, so this c we cancel this, plus c minus c, they cancel out. Okay, so we are going to be now be having 5 raised to the power 4 over 8 minus 2 raised to the power 4 over 8. And of course, that is 585 all over 8. Okay, that is what we got. That is our answer. And don't forget, what we did is that we took the indefinite integral from the definite integral and we evaluated that. And then by the time we now want to do the definite integral, there's no need to integrate anymore. We just pull our answer and then we put the limit there. That is what we did. Okay, now let's go for the second one, which is the one we are going to be following, so to say. So now in the second one, we are given the definite integral. So we say let u to be equals to t squared plus 1. Then the u becomes what? 2t dt, which means the u over 2 equals to t dt. All right. So in this one, because we are changing from t to u, we must also change the limit. The limit must also change. The limit must also change. That means what we do is that we need to evaluate what will become. This is our u equals to t this. Okay, so I will need to find when, you see, the lower limit of t is 1. So I need to find when t is 1, what will be u. The upper limit of t is 2. I need to find when t is 2, what will be u. Okay, so let's do that so that we can know what to. So when t equals to 1, what will be u? U will become what? U will become 2. U will be equals to 2. So you put t squared plus 1. Okay. When t is 2, what will be u? U will become what? U will become 5. Okay. So now let's change now from t to u and see how that works. From 1 to 2, t squared plus 1, t squared plus 1, 3 dt. Okay, so this gives us what? This now gives us 1, 2, t squared plus 1, 3. Now t dt, I brought this together. Okay, now let's change the limit now. Changing the limit, we're going to have, this becomes u raised to the power 3. This becomes the u over 2. Okay, now the limit is no more 1 and 2 because we are now in u. If you put 1 to 2 in this limit, you are very wrong, because this limit 1 and 2 is for t. Now for u, let's look for the limit. When t is 1, is 2 there. U is 2. So we are going to use that limit. So the limit to u now is 2 to 5. That is the limit to use. Please take note of that. That is the limit to use. No more 1 and 2. No more 1 and 2. Now it's fine. We can now write out the constant. Then this becomes 2 and 5 u raised to the power 3 du. Then we integrate now. 1 over 2 integrate u raised to the power 4 over 4. Then we find it with the limit 2, 5. Okay. So you see, because we change the limit, there is no need to change u back to t here. No more need to change t to u into t. If you change u into t, then you are very wrong, because now the limit is no more t. The limit is u. So leave it the way it is and just put your value there. So that means when I put 5 there, this half will be out. Okay, so I put 5 there to be 5 raised to the power 4 over 4 minus 2 raised to the power 4 over 4. Okay. Okay, excuse me. So now we can multiply this half inside. It will be 5 raised to the power 4 over 8 minus 2 raised to the power 4 over 8. Okay, which will give us the same answer we got before. You see, it will give us the same answer we got before, which is this. Yeah, which is this. You see, 5 raised to the power 4 over 8 minus 2 raised to the power 4 over 8, the same one we got here. Okay, so to quickly recap, when you are given a definite integral like this, you can either pick out the indefinite integral, taking the indefinite integral. You can either pick this out and find the integral of it and then bring it back by now putting the limit there, and then you evaluate it. Don't forget here, when we have u, we substitute it back to t, and then we evaluate it. But here in the second method, when we pick out our u, we need to now find what is the limit of u also, by picking the lower limit of t and evaluate it to find the u, pick the upper limit of t, evaluate it to find the u, and then when we change variable, when we do the substitution and we change the variable, the limit changes now from 1 to 2 to 2 to 5. Okay, anyone that gives you the upper limit, you put as the upper limit. Anyone that gives you the lower limit, you give it to your lower limit. Don't change the limit. Don't change one higher one to the lower one. No. Just follow what it gives you. When the lower one gives you 2, write 2 as the lower one. When the lower one gives you 5, when the upper one gives you 5, then write it as the upper one. Alright, so then we now evaluate. By the time we take the integral, we got this. We don't need to change this back to t. Don't change it back to t, because your limit is now in u now. Okay, so don't change it back to t. Just continue and evaluate at that point. Okay, so make sure you understand